Okay, so this video is going to be about the binomial expansion. So I'm going to start off by explaining what the binomial expansion is for. Then I'm going to talk a little bit about using the equation. Then I'm going to do a couple of practice questions, so hopefully you can get an idea of how it works. So first of all is, what is the binomial expansion for? So binomial expansion would be for, say I wanted to work out a plus b to the power of 3. Now I can work out what that is by expanding it out, multiplying out the terms, and then gathering up the like terms and simplifying it. So let me do that. So I could first of all say that would be a plus b times a plus b, and then times a plus b. Now what I'm going to do first, I'm just going to multiply two of those a plus b's. So I'm going to work out what a plus b times a plus b is equal to. So when I multiply that, I'd have to do a times a, which would give me a squared, then a times b, which would give me ab, then b times a, which would give me ab again, and then b times b, which would give me b squared. So that I could then simplify, gather up the two terms. I've got a plus b twice, so I'd get a squared plus 2ab plus b squared. Okay, so to continue with my a plus b cubed then, I can take my result that I've just had, which would be a squared plus 2ab plus b squared, and then multiply that by another a plus b. So I would need to do a squared times a, which would give me a cubed, a squared times b, which would give me a squared b, 2ab times a, which would give me 2a squared b, 2ab times b, which would give me 2ab squared, then b squared times a, which would give me ab squared, and then b squared times b, which would give me b cubed. Again, I can gather up my like terms. I would have a cubed, and then I'd have a squared b plus another 2a squared b, which would give me 3a squared b. And then I could do again 2ab squared and ab squared, which would give me 3ab squared, and then plus b cubed. Okay, so that is what I would get if I did a plus b to the power of 3. I would get my answer there. So what I've got here is that this is equal to this. Now the point of the binomial expansion is to be able to get from the beginning to the end more quickly in less steps. So you should be able to see, if I go back to the pointer here, is that I've started off with, I've got a and b both to the power of 3. So I've started off with my terms in a, and I've started with the highest power, which is a cubed, which is here. And then each time my a term is reduced by 1. So it's gone a cubed, then a squared, then a, and then no a's at all. And the other way, my b term has started off with no b's, then I've got 1b, then b squared, then b cubed. The slightly confusing thing maybe is these coefficients I've got. So the first one is 1, then I've got 3, then I've got 3, then I've got 1 again. So if I were to continue and work out a plus b to the power of 4, I could take my result from last time, multiply it by a plus b again, and gather up all the like terms. However, what I can do is skip to what the answer would be. So I would have a to the power of 4, then I would have 4a cubed b plus 6a squared b squared plus 4a b cubed, and then plus b to the power of 4. Now, again, you can see that there's started off with a to the power of the highest of the power. So because it was power of 4, I've started off with a to the power of 4, then I've gone a to the power of 3, a to the power of 2, then a, then nothing. And b's have gone the other way around, started off with no b's, b squared, b cubed, b to the power of 4. So what I need to do really is just work out how that pattern works, and then also know these coefficients. I've got 1 here, 4 here, 6 here, 4 here, 1 here. If we can work out how to get these numbers, here it was 1, 3, 3, 1, and then here 1, 4, 6, 4, 1, then that would enable us to know what the coefficients were, and then we could use the binomial expansion to work out this more quickly. So the coefficients in the binomial expansion can be calculated by using what's called Pascal's triangle. Pascal's triangle starts at the top with the number 1. You then start each line with the number 1, and it will expand. So first line will have 1 number, then 2, then 3, and so on. So at each end it will start with 1. To work out the numbers in the middle, you do add the 2 above it. So 1 plus 1 in this case would make 2. Then I start again with 1 and 1 on the end. 1 plus 2 here would make 3, and then 2 plus 1 would make 3 again. And then I would go 1, and then 1 plus 2 would make 4, 3 plus 3 would make 6, 3 plus 1 would make 4, and 1 on the end. Next line 1, and then 5, and then 10, and then 10, and then 5, and then 1, and so on. Now those numbers there would match up to the coefficients when you did the expansion. So the first line, when you did the a plus b squared here, I would end up with, using this line, I would end up with 1a squared plus 2ab plus 1b squared. When I did the a plus b cubed, I would end up with 1a cubed, 3a squared b, 3ab squared, and then 1b to the power of 3, and so on. And you can see that when I multiplied out earlier, we had the a to the power of 4, 4a cubed b, 6a squared b squared, 4ab cubed, and then 1b to the power of 4 again. So I could just use Pascal's triangle to work out the number I needed, work out what the coefficients were, and then use that. So that would be one method of using the binomial expansion. However, there's also a way that we can use the coefficient and actually work out what those numbers are as well. So what's called the binomial coefficient, which is this thing here. Okay, and that's represented in the formula, which I'll talk about a bit later. So you can work that out. So n, it's written as n choose r. You can also do it on your calculator with a button that says NCR. And that's n number and then choose a number. So in this case, if you were doing it with 4, so I would write 4 and then choose 1. I would stop, and that would be written like this. That would give me the answer of 4. And then 4 and choose 2 would give me the answer of 6. The first number, 4 and choose 0, would give me the answer of 1. So the way that the n is written is that the n is the number of the terms, the total number of the terms, or the power that you're doing. So if I was doing the fourth row with a plus b to the power of 4, I would do NCR 4, and I would write 4 choose 0, 4 choose 1, 4 choose 2. I could put those numbers in the calculator, or I can do it with n factorial over r factorial, n minus r factorial, and that will directly give me the number I need. So that's, I'll show that again a bit more in a minute, and we'll see how we get with that. So let's go back again, and then we'll try to use this binomial theorem formula here to work out what the values are. So if we do a plus b, let's do again to the power of 4. I would start off, and the first term there, it says a to the power of n. So n is 4, so I'd write it as a to the power of 4, and then plus, and then it's 4, choose 1. So I'd write 4 because n was 4, choose 1 like so. And then I'd write a to the power of n minus 1, so that would be, n was 4, so n minus 1 would be 3, and then b. Okay, and then it says plus, plus, plus. What's written next is the nr, and then a, n minus r, b, r is the general term. So n is still 4. R is the number of the terms that we're on. So we start off with 0, then 1, then this would be 2. And then it would be a to the power, and then 4 take away 2, so that would be squared, and then b to the power of 2, which would be there. Then the next term now would be on the third term, so we'd do 4 choose 3, and we'd have a and then b to the power of 3, and then the last one we'd have 4 choose 4, and then that would be, the a's would be gone, it would be just b to the power of 4. Now 4 choose 4 is 1, so that's why it's skipped out in the formula, so I could actually rub that out and not have it. Let's just remove that like that. Okay, so that's what the thing is telling us. Now we can use a calculator. We can use the n factorial over r factorial, n minus r factorial. So for doing 4 choose 1, I can say, let's just use a different color. So if I do 4 choose 1 like that, it would be 4 factorial over, and then 1 factorial, and then n minus r, which would be 3 factorial. So 4 factorial would be 1 times 2 times 3 times 4. 1 factorial would just be 1, and then 3 would be 1 times 2 times 3. So I could see that my 1, 1, 2, 3, 1, 2, 3 would all cancel out, and the answer would just be 4. Okay, so that general formula will work for whatever it is. It's more useful when you're doing, say, a plus b to the power of 15 or something, and you don't want to work out the whole of Pascal's triangle for it. But you can use that formula at any point. You can also put it in your calculator if your calculator has an NCR button and it is permitted in the exam that you're doing. All right, but getting those values, that's just the formula for how to get the values for the coefficients. All right, and then the binomial theorem formula there is showing you the general formula of how to work it out. So that's how the binomial expansion works, and I'll then do some questions to simulate exactly what's happening. So here I have an actual question. It says, find the first four terms of the binomial expansion in ascending powers of x of 1 plus x to the power of 4, and then that is what, all to the power of 8, by the looks of it. And giving each term its simplest form. Okay, so what I'm going to need to do then is to put that in the form, so what we were talking about previously was having a plus b, and then to the power of n. So that's all to the power of 8. So if I imagine that it said a plus b all to the power of 8, like that, I'll be able to work that out, and I'd start off with my a to the power of 8, and then I'd have 8 choose 1, a to the power of 7b, and then I'd have 8 choose 2, a to the 6b squared. That's 1, 2, 3 terms, and then I'd have 8 choose 3, a to the power of 5b cubed. So that would be the first four terms. Then I'd have plus dot 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 dot. Okay. Now what I need to do is actually fit that sort of, or the question we've got into that format. So instead of a, I've got 1, and instead of b, I've got x over 4. And then I also need to work out what a choose 1 would be, a choose 2 would be, and a choose 3 would be. So let's start off with my, oops, what have I got here? My a would be 1, so I'd start off with 1 to the power of 8. Then I'd have 8 choose 1, which would be 8, and then 1 times 1 to the power of 7, and then times my b, which is x over 4. So I'm just going to write the whole of x over 4 in place of b. Then I've got 8 choose 2, which is 28, and then times 1 to the power of 6, and then times x over 4 squared, since my b was x over 4, so just substitute the whole of b for x over 4, then plus 8 choose 3, which is 56, 1 to the power of 5, and then times x over 4 cubed. Okay, so now all I need to do is just simplify that, and then I should have my solution. So I would then say 1 to the power of 8 is obviously 1, and then 8 times 1 to the power of 7 would just be 8, times x over 4. So 8x over 4 would simplify to be 2x. Then I'm going to have plus 28, and then that's going to be x squared over 16, which I'll simplify down in a second. And then I'm going to have 56 x cubed, and that is going to be over 4 cubed, which is 64. So then I just need to simplify it down a little bit more. So it's going to be 1 plus 2x, and then I can divide both those by 4, and so that's 7 over 4. And I can divide both of those by 8, and say that that's 7x cubed over 8. So the first four terms, I guess there'll be more terms than that, but in answering the question, it said, so find the first four terms of the binomial expansion in ascending powers of x of that, then giving each term its simplest form. So that's exactly what I've got. So I've got 1 plus 2x plus 7x squared over 4 plus 7x cubed over 8 plus dot dot dot, and that's my first four terms. So part B says, use your expansion to estimate the value of 1.025 to the power of 8, giving your answer to 4 decimal places. So if we've got to do here is see the connection between this 1 plus x over 4 to the power of 8, and then using that to work out the value of 1.025 to the power of 8. So this is part B. So we've got 1 plus x over 4 to the power of 8, and that approximately equals the answer I've just got up there. 1 plus 2x plus 7x squared over 4 plus 7x cubed over 8. And what I need to do is work out 1.025 to the power of 8 using that result. So what I need to see is the connection between 1 plus x over 4 and 1.025, both of them to the power of 8. So what I need to do is equate the 1 plus x over 4 is equal to 1.025, work out what the value of x is, and then substitute that into the formula. So in that case, I would work out that x is going to be 0.1. Just rearranging that there, subtracting 1 from both sides, and then multiplying by 4. So I get x is 0.1. So I just need to substitute into my approximation 4 with x is 0.1. So 1.025 to the power of 8 is going to approximately equal 1 plus 2 times 0.1 plus 7 times 0.1 squared over 4 plus 7 times 0.1 cubed over 8. Once you've got that, you can stick that in your calculator and then you can work out what the answer is. So when I work that out with my calculator, I get the answer of, let's just move that where you can see it, 1.218375. 1.218375. Okay, now I can check that is right just by doing 1.025 to the power of 8 and checking that that is pretty much the same thing. So if I do 1.025 and then to the power of 8, I've done that wrong. 1.025 power of 8 equals 1.284. So I can see that my binomial expansion is more or less correct. So I've got that accurate to a certain number of decimal places. Now it is an approximation, so that's why it's going to veer off after a while, but that is going to correctly answer the question.